Hi friends, this session provides an overview of Microsoft Foundry Local, that is a developer-focused service that enables running and testing large language models, or simply LLMs, directly on a local machine. This offers a fast, flexible, and secure way to integrate AI capabilities into applications. So this is a practical session with a live demonstration, and before jumping to the live demonstration, first we're going to talk a bit about Microsoft Foundry Local to learn more about it. So what is Foundry Local? Foundry Local is a free LLM service provided by Microsoft, which is designed for developers who want to run large language models locally. To this end, it exposes an OpenAI-compatible REST API, thus allowing easy integration with existing workflows and tools. This makes it particularly effective for scenarios involving rapid prototyping, testing, and iteration. So, why is Microsoft Foundry Local useful? Well, running models locally reduces latency and accelerates development cycles. Also, it provides full control over the environment and data, ensuring secure and predictable experimentation. Foundry Local integrates smoothly with existing tools, thus making it a strong foundation for early-stage co-pilot development. Now, regarding how Foundry Local works, it's pretty straightforward. First, you need to install Foundry Local, then run a model from the available catalog, and interact with it using the provided REST API. Since the API follows the OpenAI format, integration is simple and can be done from Python, command line interfaces, or any tool that supports HTTP requests. At the time of recording this video, Foundry Local is currently available in public preview. As stated by Microsoft, features, approaches, and processes may change before general availability. Moreover, some capabilities may also be limited during this preview stage. Great! Now we are ready to proceed with our live demonstration. To this end, in the upcoming demo, I will illustrate how to install and check Foundry Local status, run a model locally, and consume its REST API from a Python program. Essentially, for the purposes of this live demonstration, we'll be building a simple chatbot in Python for demonstrating how easily a local LLM can be integrated into an application using Foundry Local. Great, let's proceed. So the first thing is to install Foundry Local. So here we are in our command prompt, and the command we need to use, since we are on Windows, it's winget install microsoft.foundrylocal. So you see, Foundry Local started to be installed on our machine. Depending on your internet connection, it might take a while in order to complete. And a few moments later, we can see that Foundry Local has been installed on our demo environment. So now we can start running Foundry Local commands using the Foundry command. If we want to see the available commands, each time we are trying to run a command, we can use the /? So you can see the basic commands we can use now is Foundry, model, cache, or service. So for example, let's run Foundry service status to check the status. You see, Foundry Local service is not started yet. We need to start it. So the way to do this is Foundry service start, but before starting the service, at any point in the command line, if we use /? We get the available commands for the command we're trying to use. So you see, for the Foundry service command, we have these options. So it is Foundry service, list, start, stop, restart, status, and so on. So let's run Foundry service start in order to start the service. Okay, service has been started. We can check the status. You see, our service, the endpoint, listens on this address. So for example, if I copy this and paste it in a browser, you see, this is our endpoint. But before using Foundry Local, first we need to load a model. We need to run a model. So back in the command prompt, we use Foundry model list, for example, to see the available models. So you see, these are models we can use with Foundry Local at this time. So I'll be using something simple for our demo. And since I don't have a GPU on my system, I will be using a CPU model. So let's run the model Qwen 2.5-0.5b for CPU. So I'm copying the exact model name here. You see here the CPU part. Okay. And the command is foundry model run, and we put the name of the model here. Now this command downloads the model locally in the cache, and you see it has been loaded successfully, and now I'm ready to use the model. So now, since the model is loaded, Foundry Local enters an interactive mode, and here I can try the model interactively using prompts. For example, what is the capital of France? You see, it's quite fast, right? Of course, this depends on your system as well, the CPU architecture. In case you want to use a GPU model, it depends on the computational power of your GPU and so on. Why the sea is blue, for example. So you see, I'm interacting with the model, and this model was downloaded and started using Foundry Local, and now this model exists in Foundry Local's cache. So now the next step is to consume this model, which is currently running, using the endpoint offered by Foundry Local. And the endpoint is here. So I have written a simple Python application to illustrate this. So this is my application. So you see, first I'm importing requests library. Then I need to specify the Foundry Local URL. So you see, this is the IP and the port. The port is 61476. This port is dynamic. You see, in my code I had a different port, now it's a different one. So this depends. It's a dynamic port, and every time you run it, it might be different, since this is used for development purposes. And you need to add the v1 chat completions here, since this is an OpenAI-compatible endpoint. The next step is to implement a function, in this example the askFoundry function, which is responsible for sending the user's prompt to the model. Essentially, this function builds a JSON payload containing the model name and the message, and sends a post request, and finally extracts the model's reply from the response. So you see here, I'm constructing the payload. You see, I'm specifying the model name, in the message role, user, and content. And here, I'm extracting the model's reply from the response. The run chat function, it simply sets a terminal interface. So to this end, it waits for input, passes the text to the model, and prints the model's response. By typing exit or quit, the chat is closed. Finally, in my Python program, I include a standard Python entry point, so when the file is run directly, it starts the chat loop automatically. So we are ready to run our program. So you see, we are connected to the Foundry Local service endpoint, and through this endpoint, we connect to the model that is currently running through Foundry Local. In this case, it's the model, as said earlier, Qwen 2.5. It is the CPU-enabled model, so let's try some prompts. Let's try the same prompt we tried earlier in the interactive mode right after we ran the model in the Foundry Local command prompt. So let's say hello. What is the capital of France? So you see here we get the answer from our model. The capital of France is Paris. It provides some more information, and you can see here it elaborates even more. So let's ask something else. For example, how many moons does Jupiter have? You see, we get our answer that Jupiter has approximately 79 known moons, and it elaborates even more. So you see, through this implementation, this simple Python implementation, and essentially via the Ask Foundry function we implemented here, we construct a JSON payload and we send this payload to Foundry Local, and Foundry Local passes this payload to the model that is currently running locally on our machine, so no internet is required, no subscriptions, not anything. Inference takes place locally on our machine, and when this JSON is delivered to the model, we get a response, and we parse this response in order to return to the user, to the screen, the response of the model based on the prompt we sent earlier. So this is a simple implementation, but the benefits are many. So you can see you can easily experiment with models. Foundry Local supports many models. So let's go again back to the prompt. Another prompt here to see the list of models again. You see it supports the Phi model, variations of Phi, Mistral, DeepSeek, Qwen. So you can easily run a model through Foundry Local, locally on your machine, and connect your application in the exposed endpoint by Foundry Local and the model that is currently running. So this is very important, and I hope that this demo helped you understand how easy it is to utilize this capability. So let's wrap up this presentation and live demonstration. In summary, we can say that Microsoft Foundry Local provides a practical and efficient way to run and test the language models directly on a local machine. Also, its OpenAI-compatible REST API makes it easy to integrate with existing tools and applications, thus enabling faster prototyping and iteration. Last but not least, as said earlier, this is still in public preview, so capabilities may evolve and change prior to general availability and after general availability, so it's important to keep this in mind as well. Thank you very much for watching this lecture and live demonstration, and I really hope that you found the subject as exciting as I did. If you'd like more insights on AI, data, digital transformation, and other tech trends, be sure to subscribe to my YouTube channel. Take care, and I'll see you next time.